Hey, today, day 2 of graphing polynomial functions. So, you got about a minute per problem here. Okay? All right, how many got number 4 correct? F of 4 equals -7. Okay, common mistake right here, multiplying 3 by 4 and then squaring it versus going 4 squared and then multiplying by 3. Those of you just plug it into your calculator, make sure that you understand that rule. It's going to haunt you this year if you don't. Okay?
How can we fix it? Like, I just plugged it in like that, but can it go wrong? Like, if you plugged it in just like it's like right there, could it ever go wrong?
Like right here?
Like, yeah, I plugged that in.
No. However, you guys need to get to the point where I realize in your age, like technology is a big thing, but you should be able to do error analysis. That's really what you need to be able to do and go, whoa, that doesn't seem right. Okay, that doesn't appear to be right, and then you should be able to check it by hand. Okay, and some of your teachers, me included, probably won't be on this test, but there will be times when I say, sorry, dude, you can't use that graphing calculator. You can't use that calculator today. It's a by hand test. All this you should be able to do by hand. And the only way you get better at it is if you do it by hand. So if you rely on your calculator all the time, helps you until you don't know the rules. So if you're like, I don't even know what he's talking about there, but I don't care because I got my calculator. Okay. You better understand the rules of order operations. It's a basic rule, right? So 4 squared is 16, then multiply by 3. So PIMDAS, for those of you who think of it that way, exponents and then multiplication. Okay? But to answer your question, if you plug that exactly like that in your calculator, you should not have a problem. All right, number 5. Put up that work there. Bless you. Okay, -2 to the 5th is, anytime you raise a negative to an odd power, you get a negative. So that is -32. And then negative to an even power is a positive. In that case, it gives you 16. That becomes plus 12. -108 plus 12. -96 plus 10. F of -2 is -86. Okay. How many got it? All right, what's the problem? -96 minus 16 equals 108. -108, yes. Oh, -112. Okay, once again, it's not always that your calculator can do it. It is called what? Error analysis. You're analyzing, trying to find the error. So, very good, Dallas. You were actually paying attention as I was doing the math. -112 plus 12, or -96 minus 16 is not -108. It is -112. We add 12, we get 100. Add another 10, we get, or -100. Add another 10, we get -90. That is the correct answer. Okay, now how many of you just changed it right away? You're like, all right, well, okay. Hopefully you're figuring out what you did wrong. If you're like, I don't even know because I just put it in my calculator and I just I can compare. Well, that's a problem. All right? I really am trying to make a point here. Know what you're doing and be able to show what you're doing, showing your work. All right? Describe the end behavior. What do we got? Positive coefficient, it's an odd. An odd says they go in opposite directions. Positive coefficient means it has a positive slope. If you think of it that way, it looks like that. And then we just break that slope into two separate pieces, which makes it down, up. There it is. Okay? Those of you that write it in, that want to write it in the f of x format where you'd have x goes from negative infinity as f of x goes to that's representing this arrow right here. Okay? And then saying x goes to, that arrow would be positive infinity, as f of x goes to positive infinity. And the book reads it, and it probably is more accurate to say as x does this, f of x does this. I write it like that. The book writes it in reverse order. Okay, I'll be fine with either order. Okay, if you just put this, that is okay. Yes?
So it's okay for f of x first?
Yes, if you put f of x first, it says f of x approaches negative infinity as x approaches negative infinity. That's fine. I probably prefer the other way just because the book does it that way. I have always wrote it like this, so I will obviously revert to this method. I will accept either method. Okay, just know what you're reading. All right, I want you to take a look at page 80 of your student journal, please. We will. Okay, take a look at page 80 of your student journal. We are not going to do problems 10 and 11 on there. However, we are going to do problem 12 to begin with right now. So I want you to work with your groupies. It's a sketch. It does not mean it has to be perfect. Do your best sketch on number 12 there. Yeah, those of you needed that again. There it is. I got rid of that second word as. I heard some of you still talking about it. Okay. But don't spend too much time on that. I want you guys to really spend some time on number 12 real quick. Hey, here we go. So, first thing you need to do is actually draw an XY axis. Okay, and when x, if we identify each going, or the x-axis going up by units, we say as x is less than -1, f is increasing. So this is f. This is our x-axis. So as x is less than -1, so that's on to the left of that point, x is f is increasing. So we are increasing. We're going up from left to right until we get to -1. Okay? It also says we're increasing when x is greater than 0 but less than 1. So in between 0 and 1, we are also increasing. So be something maybe like that. Okay? Now, it doesn't mean you have to end at that point there necessarily. Okay? It says that f is decreasing when x is less than -1. Or, excuse me, when x is greater than -1, it's decreasing, but less than 0. So I'm going to use the dashed line just to show that. So decreasing right here. And then it's also decreasing when x is greater than 1. So on this side of 1. Okay? So it looked like something like that. Yeah, the golden arches. All right. We're loving it. Well done, Zach. All right. Okay, now, really the only thing that has to hold true is how your curve is going up or down. I mean, where it's hitting Y or the F axis, it doesn't matter. Okay? It could have been further down, further up. It really does not have a bearing. Just that it changes direction on this line, and changes direction on that line, and changes direction on that line. Okay, so describe the degree and the leading coefficient. So therefore, since this is down, down, what type of degree is it? It's an even degree with what type of leading coefficient? Negative leading coefficient. All right. Even degree, negative leading coefficient. Well done. Questions?
Is there a way to tell what degree it is based on the curve?
We don't know for sure on that. No. Okay. Other questions? The problem when you get to calculus, you could. Okay. But we'd need a little more info than that, I think. Okay. All right, guys. Number 13, we'll do here in a few minutes. But before we do that, I want to go through yesterday's assignment. Okay. Right now, I'd like you to take a look at problem 13. You'll need a graphing calculator. This is in your student journal. I don't want to spend tons of time on it, but I want to put a little time into it. Okay? So, you're able to go get your graphing calculator out. Please set your window. Set your window so that you get that interval. Okay? So first, put that into your y equals menu, and then we'll get your window set. All right. Once you get it plugged in there, that actually becomes your standard viewing window, but it's giving you the interval. It's saying from 0, where t is greater than 0 and less than 5. So in other words, your t-axis, which in this case is our x variable, goes from 0 to 5. So if we go to our window, we want our x minimum to be 0 and our x maximum to be 5. Okay? We'll still go up by 1 because t represents the number of years since 2010. So we can go up by every 1 year. And then our y-axis, we'll just, let's go ahead, since S stands for number of students in thousands, will we exist in the negative here? I mean, we have negative students, but we're not going to count negative students, right? We're going to only count the positive ones. No. There we go. Okay? That's what we've got. That doesn't show us much of anything, right? What's the problem with that? Okay, what's our y-intercept? 23, you guys. I know it's a sad thought, but I will not always be there to help you out in math. I know. There will be a point at which you're sitting at your kitchen table or down at Hagen's. You're like, dude, McCoy's not even here. He can't even tell me why my graph doesn't appear. So you have to look at y-intercept is 23. So I always try to go to zoom fit if I can. See if that works out. Zoom fit. See if that'll help. And okay, the only problem with zoom fit is now adjusted my y-axis, but it also just, anytime you zoom, it also adjusts your window. So all that stuff I did with my window could have changed here. In this case, my x stayed the same, 0 to 5, which is what I wanted. Very good, but it did adjust my y. So I've got it. There's my picture. Okay, you guys go to zoom fit? Very good. Not Zumba. Zoom fit. Now, does everyone's graph look like that? Okay. Now, after we graph it, now you could draw a picture of it here. Describe the behavior of the graph in the interval. Okay, looks for like from 2010, which is here. That's 2011, 12, 13, 14, and 15. Okay, so from 2010 to 2000, looks like about 12-ish, or halfway through 12, my graph is doing what? It's rising, which means the number of students in thousands who graduate are going up. Until you get to mid-2012, what starts happening? Yeah, they're gone. I don't know what happened to them. Okay? Yeah, maybe so. Okay, around mid-year, the students start declining. All right? Let's go ahead and answer question or letter B here. The average rate of change, what is the average rate of change in the number of students, a 4-year graduates from 2010 to 2015. Now, where could we look for that? Okay, what is the average rate or the number of students in thousands that graduated in 2010? That's your Y-intercept. Okay, 23,000. How many in 2015, which is over here? Go to your, hey, let's go to our table. What value are we looking at table? 2015. Okay, time equals 0 in what year? Time equals 0 in 2010. So 1 is 2011, 2 is 2012. What is 2015? Yeah, it's 5. Okay. How many students graduated in 2015? 16,750. Right? It's in thousands. Okay? So if I am going down, if I'm trying to find the average rate of change, how much did I change right here? Good, 6,250. Okay, in how many years? In 5 years. So what is my average rate of change per year? Yeah, it would be 1,250 students per year. I'm not failing, just maybe not graduating as quickly. Let's go positive about it, okay? Okay, what do you guys think? Do you think this model could be used for 2010 or years before 2010 or years after 2015?
Like the equation?
No, the model. So this, yeah, the equation. I mean, a lot of times the models we come up with are only good for a certain interval. Is it realistic that we think that no students are going to graduate? I mean, right, if we continue this table, this trend here, look, that doesn't seem...
What does that mean, negative students?
Yeah, that means it's no longer accurate, obviously, after this point, but it's probably not as accurate here. Okay, and if we take a look at it prior, okay, notice how many students are graduating in years prior to 2010. Does that look accurate? That's a lot of thousands. 286,000 students if we round. Okay. All right, so probably not as accurate. So just keeping in mind that models are not always accurate after certain intervals. We only use our models for certain intervals sometimes. Okay, I want to take a look at this next page real quick. This is the page you picked up on the way in. What I'd like you to do is I'd like you to list the X-Intercepts. Okay, you get 30 seconds. X-Intercepts, off you go. Alrighty-o. What are my X-Intercepts? 5, -5, and 1. It's what makes those 0. So what we're going to do is we're going to actually put points at those points. 1, 2, 3, 4, 5. -5, 1, 2, 3, 4, 5, and 1 right there. Now I'm going to tell you, you don't have to find the Y-intercept here. The only place that our graphs today are going to be accurate when we're sketching these graphs are at our zeros, and that's it, and our end behavior. If you want to make the Y-intercept accurate, you could say -5 times 5 is -25 times -1 is +25. My Y-intercept is 25. So somewhere up here you can say, yeah, it's 25, if you really want to. I'm not going to make you do that on this. So I know that this is a x times x times x, or what degree? This is the 3rd degree. Okay? This is what y equals. You don't have to have that. My x-intercepts are here. X equals those things. And I'm going to know that a 3rd degree has an end behavior of down, up. So I'm going to start down here. I'm going to end up here. What I need to do is I need to go through these points to get there. So I'm going to go up through that point. I'm going to jump down through that point. And then I'm going to pump back up through that point. Done. Now, hold on a second. The only place where this graph is accurate, once again, there, and my end behaviors. That's it. So those of you that have math junkie parents, that's like they dream of you coming home with questions or homework, and they go, that's not even accurate. My goodness. Well, explain. Look, it's only accurate here, here, and here, and here. That's it. Okay? I realize the rest of the graph is not accurate. That's okay. That's what I want you to know. Yes, Walsh. Okay? Any questions? All right. Well, let's try this one. List all your zeros. Hey, time's up. What's 1 0? -2. In fact, how many -2s are there? There are 2. For those of you who are like, huh? How are there 2? Well, that says x plus 2 times x plus 2. That's what that second power means. Quick way is to go, oh, that has a second power. That means there's 2 of those. Is that important? Yes, that's important. Correct. And this is 1. So what I'm going to go is I'm going to go to -2, and I'm going to go to 1. Now, this is a what degree? Good. It's a second degree plus a 1 degree or a third degree. Now, third degrees, as we reviewed just in the last problem, is a down-up. And I've got to start down here, and I've got to end up there. I want you to draw a line that goes through those points, or hits those points, starts down here, and ends up there. Okay, what can we do?
Again.
Yes, what can I do?
Okay, so you go up to the -2.
Okay.
You also slope down as you hit the -2 like a quadratic gravel up like that. Because it's -2 twice, so you have to go around it.
Okay, now what?
You go back up.
Oh, go back up. Okay. Very good. Now, if you want to find the y-intercept, once again, you can. And you guys, sometimes the y-intercept, note that's 2 times 2, which is 4 times -1 is -4. The y-intercept, dude, I didn't even plan that. Okay? The y-intercept sometimes helps you to realize you're on the right track. Notice you bounced here, or you turned. You turned right there. Okay? My x-intercepts were 2, 2, and 1. You have a multiplicity. We call that a multiplicity. Oh, -2. Thank you. We have a multiplicity of 2 at -2. There are multiple zeros. Yes? Can we go through these first? Okay. Why don't you guys try that one? Write your zero. Okay, x equals what here? 0. How many times? Twice. So we get 0 and 0. 3 times. And degree is? 5th degree, which means it starts down and goes up. Okay? Does that. All right? We hit 0 and we hit -3. Now, I'm going to show you how to do this one. Thank you. That could have been bad. All right. Now, this has an even multiplicity and an odd multiplicity. This is even because there are an even number of zeros, not because we consider 0 an even number like 10. It's even because there are 2 of them. This is odd because there are 3 of them. This was an even multiplicity here. Okay? Okay, even multiplicity and odd multiplicity. Okay? So, at an even multiplicity, we found we changed directions up here. At an odd multiplicity, we do something different. But anytime there's a multiplicity, something happens at your graph. It can't just go straight through it like we did when there's only one of those. Okay? So at an even, we know we change directions. this is going to have to end by going upward, which means if I'm turning at an even number, because there are two of those, that should look like that in my middle section of my graph. Okay, that's how the graph ends. Now that would mean that I have to come through here, and some people would say, well, can't you just go straight down? Well, the answer is no, because something has to happen at an odd number of zeros. You get what's called we call it a slide. That's kind of a slang term. Okay, it looks like this. You start going up like you're going in a parabola. And then from this point here, you go down like you're doing the bottom of the parabola. You slide. Okay? It's kind of like an S shape through there. It's super cool. Yeah, like S. Super cool. Okay? Yeah. Ha, ha, ha. All right. There we got it. So we had a slide and we had a bounce or a turn.
So if it's a slide, it just kind of like
Starts here, go out and up, out and down. Okay? Take a look at the next one. Turn the page. Okay, I want you to go ahead and give that one a go. List your X-Intercepts. List your degree. List your end behavior. I bet. Everyone figure out why it's Walsh's favorite one.
thanks for ruining the game, Jacob.
All right. Be nice. W. Okay, how we doing on it? Okay, I want you to try the last two while I am handing out today's stuff. Okay? Try those last two. I'll put up the answers here in a minute. All right, the last two.
I'm almost done.
I actually have the Y-intercept on that one. Good question. Is this like a quadratic? It kind of looks like a parabola. It's really flat. The higher that degree, even-wise, the flatter that is getting. Think of it as a flat tire. Okay, if that becomes like a 10th degree, that is a really flat bottom on it. Okay?
And same with the slide, like the bigger it gets, the more flatter.
Yeah. Yeah, at the point of sliding. Yeah. Now, I'm just worried right now that you're actually changing directions. Okay, you're either bouncing or sliding. Okay, or turning and sliding. Okay? Any questions? Your assignment is everything on this other page that I gave you today. On the front and on the back, with the exception of the last 8 problems. The very bottom. Yeah. Just don't cross them out. Just don't do them right now. Okay? All right. Very good.